Let's talk about approaches for improving classification model performance. Starting with Ensemble methods. Ensemble methods involve training multiple models and combining their predictions to make a final prediction. This can lead to improved performance as the ensemble is able to make use of the strengths of each individual model. An ensemble consists of creating a series of base models with the aim of creating a single classification model that is a combination of all the other models. For a given dataset, the ensemble returns the prediction based on the votes of these base models. Ensemble models are more accurate than a single classification model. When there is little to no correlation between the base models, the ensemble performs better and can be parallelized, thus improving the performance. Let's talk about different types of ensembles. Bagging. Bagging aims to reduce the variance of a single model through the use of multiple models and the final prediction being an average of all the models. Let's understand it through an example. Suppose you are a patient and you would like to have a diagnosis made based on your symptoms. Instead of asking one doctor, you may choose to ask several, and if a certain diagnosis occurs more than any other, you may choose this as the final or best diagnosis. That is, the final diagnosis is made based on the majority vote. Similarly, in bagging, the training data is divided into a number of subsets or bags, and a separate model is trained on each bag. As a result, the final model is more stable and less prone to overfitting, and the final prediction is an average of all the models. Bagging is often used with decision tree models, but it can be applied to other types of models as well and can work well with high variance models. Boosting. Boosting is an ensemble technique that involves training a sequence of models that try to correct the mistakes of the previous models. The final prediction is made by combining the predictions of all the individual models. Taking the same example of consulting the doctors, suppose you assign weights to the value or worth of each doctor's diagnosis based on the accuracies of previous diagnoses that they have made. The final diagnosis is then a combination of the weighted diagnosis. And this is the essence behind boosting. Boosting involves training weak models that are only slightly better than random guessing. And each model in the sequence is trained on the errors made by the previous model, so that the final model is able to correct the mistakes of all the previous models. There are several popular boosting algorithms such as AdaBoost, gradient boosting, and XGBoost. Boosting can improve the model performance significantly. However, it is prone to overfitting and requires iterations to tune the model appropriately. Random forest. It is another ensemble method that is a collection of large number of decision trees. It can be used for both classification and regression tasks. It uses a bagging algorithm that means the final prediction is an average of all the models. As a result of using bagging, the final model is stable and has better generalized performance. There are several benefits of using a random forest, such as they are easy to use and can handle high dimensionality datasets. They can handle missing values and categorical variables, and they are less prone to overfitting. Let's talk about a few other approaches for improving classification model performance. A model performance can often be improved by increasing the amount of training data so it can learn more about the patterns, leading to better predictions. Another approach is using a more powerful model with more parameters or complex architecture. However, as the model becomes complex, there are chances of overfitting. That is, the model performing good on training data but worse on unseen data. Another approach is selecting and engineering different features that are used as input to the model. Regularization can help in preventing overfitting through the use of penalties on the model's loss function, and it can help in better generalization, that is, the model works well on unseen data as well.